Hi guys, I'm Jack. This video is about cycl3 and today is September 28th. Today's video is about static routing and inter-VLAN routing, chapter 16, 17, 18, 25, and review 8. Let's start with chapter 6. Configuring IP version 4 addresses. IP routing, the process of forwarding IP packets, and it requires layer 3 logic, so the routers compare the destination addresses in the packet to routing tables. Also, due to IP routing rules, they're searching for the path to the host IP destination first. And secondly, if there's no host IP address or unmatched IP addresses, they're looking for the matched network address pathway. However, if they cannot find it, they will be shown as default gateway 0.0.0.0.1 and IP version 4. We have talked about this before, so I will briefly talk about it. Internet Protocol version 4, and it makes use to connect our devices to the web. Whenever a device accesses the network, it is assigned a unique IP address. There are rules in IP routing. First is if the destination is local, send directly, which means that destination address is in same network with mine. It will send directly to it. Second is if the destination is not local, send to the default gateway. As I said, if destination address is not in same network, they will send it to the default gateway. Alright, I will make it more easy to understand. Check this picture. So our host A sends a local packet or data to D, which is direct way. However, B is on the other side, which means they're in different subnet. So the point is that they're not local, so as I mentioned, if the destination is not local, they will send to the default gateway, to B. Next, host routing logic summary. Obviously, routers have more routing work to do than host, because it is router. Router has particular process to be done before getting to the point. We call that 5-step summary of a router's routing logic. The first 2 steps is just for receiving the frame and extract the IP packet. First is for each received data link frame, choose whether or not to process the frame. Process it if the frame has no errors or the frame's destination data link address is the router's address. So it first filter that whether they do process or not. They do make decision. Second, after step 1, encapsulate the packet from inside the data link frame, and the encapsulate can be illustrated like this. Third, making a route decision, comparing the packet's destination IP address, so routing table for the routing table and find the matched destination addresses too. Next, we do encapsulate the packet into a data link frame appropriate for the outgoing interface. We do encapsulate this time, and using ARP is needed to find the next device MAC address. Because the reason why we're using ARP is simple. To transmit the data, we should find MAC address and IP addresses too. So ARP helps us to get MAC address from IP address through broadcasting ARP request. The last step would be transmitting the frame out the outgoing interface. After we have done all process, there's only one job to do: transmitting. Okay, configuring IP addresses and connected routes. We all know that Cisco routers are routing globally, and the interface must be configured with an IP address and must be configured too. When we see the line status up or line protocol up, means it is working well, like this. It shows the state up and line up in here, which means it is working well. Also, routers can add routes to their routing tables with those methods. Connected routes, added because of the configuration of the IP address interface subcommand on the local router. Static routes, added because of IP route global command on the local router. And admin is putting the destination network information him or herself, because router cannot reach automatically itself to network. And routing protocols are added as function by configuration on all routers. It makes decisions through routing table. And in addition, routing table has information about the destination network and which way to get the network, and place only the optimal routes on the routing table. Configuration of routing table is show IP route. And this is how exactly look like when we do show IP route. So C as connected, which means they're connected well in the gateway. Connected routes and the IP address command. Cisco router automatically adds a route to its routing table for the subnet connected to each interface. The interface is in a working state, which means in the interface status in the show interfaces command, it lists the line status of up and protocol status of up. As I mentioned, it is working well. Also, the interface has an IP address assigned through the IP addresses interface subcommand. Connected routes is very easy and basic. Each device requires subnetted number to connect each devices so that other router can route packets to the subnet. The ARP table on a Cisco router. After a router has added these connected routes, the router can use route at IP version 4 packets between subnets. To do so, IP ARP table should be created. Since the IP addresses of the communication host is usually entered directly by the application user in the process of running the program, so obtaining the incoming host MAC address from the IP address is additionally required. How to check is simple. Show IP ARP, and in this picture we can see the ARP is 172.16.9.1.9, and it transmits the frame out interface giga 0/0. We have many ways to figure out what choice a router makes for choosing the best route. Let's use show IP route OSPF command. So OSPF means open shortest path first. Look at the picture, and this shows the series of overlapping routes. O means OSPF, and down below we can see line and which one is OSPF here. Next one is using IP route address to find the best route. This is a second way to identify the route a router will use. We'll use show IP route and address command, and the reason why I used address is the IP address of an assumed IP packet. It replies by listing the route it would use to route a packet sent to address. So the first line shows output list the matched route, and other things are just details about it. Chapter 17. Configuring ROAS. So ROAS means router on a stick. It uses router VLAN trunking config to give a router a logical router interface connected to VLAN. And sub-interfaces Cisco created multiple virtual router interfaces, one associated with each VLAN on the trunk, because the router has only one physical interface to connect to the trunk. This is trunking on a router configuration for the 802.1Q. We talked about how to trunk config before, so I will just pass it. Look at the sub interface numbers 0/0.10. The number can be any number 1 to billions. We can just think as it is just unique number with this one physical interface. The funny thing is the sub interface number doesn't even have to match with associated VLAN ID. And this is router configuration using native VLAN 10 router B1. So these two different sections shows both native VLAN config. VLAN 10 becomes a native VLAN, and first part shows that configuring the router physical interface. And the second one shows how to configure the same native VLAN on a sub interface. The major point is that they have to change VLAN 10 to native VLAN. And verifying ROAS configuration is show IP route connected. Now we see L is local and C is connected. C as connected and L as local in here. I will show you another config. Look at the picture. It shows that if physical interface is shut down with the sub interfaces, then automatically changed to an administratively down state. As a result, we can do config terminal and put the interface number and shutdown too. As we can see, using shutdown commands, it can disable it too. Let's go to the chapter 18, troubleshooting IP version 4 routing. We are all familiar with ping and ping command. When our ping command succeeds, it confirms how IP routing works and to show the current problem. Also, when ping fails, it often helps list down where did the problem happen, further isolating the problem. This shows ping to particular IP and shows the result. And under the ping statistics, we can see 6 packets transmitted and received and lost. As this ping command can show very useful options. And check this picture too. I did ping to same IP address, and at the first time success rate is 80%. It means one failure to start. However, on second try, it worked well. Why? This can happen because some device in the end-to-end route is missing ARP table entry. And now we're going to learn how to use extended ping to test the reverse route. Pinging is very useful, but it can miss an opportunity to test IP routes fully. It doesn't test the reverse routes back towards the original host. Let's see the sample. Thing extended ping command allow use to put all parameters, but also we can use just ping command. So we can see the IP address and it will ask us to put command down. But why in extended commands and the source address? So we should put Y as yes in there. That is IP address of router or switch to router where we send the packets in here. Also in this example, we can just put ping target IP address source address. Okay, and this is testing LAN neighbors with standard ping. We see what is in the picture. Echo request happened from router 1, so ICMP messages awkward if router 1 issues the command ping 172.16.1.51 to host A and get fully reply from user A. It means the LAN can pass unicast frames from router 1 to host 172, 16, 151, and vice versa. Before we get to know about Telnet and SSH, I will explain traceroute. So, what is traceroute? Yes, it is just tracking command in window. It basically gathers all the information by gathering packets. When you enter destination as an IP address or URL, each interval displays the name, address, and time taken of gateway computer. Check this picture. I put tracer and address, and to reach kns.coordinate, don't mind about it, I go through various equipments you can see in here, and that's numbers doesn't look like normal. It means it needs troubleshooting. Also, in this picture, we see something like a star mark, and well, this one means it hasn't been open or secured server, but you have been passed. Let's learn about Telnet and SSH. Ping and traceroute is very good command, but these two commands tells us nothing about operation state inside the various network devices, and using Telnet or SSH can allow us to look at the status of various router and switch. Moving on to the chapter 25, we're going to talk about IP version 6 routing. Static IP version 6 routes are set directly by the administrator, and this is an example. First, I would like to connect two PCs with different routers. To communicate with two different routers, I have to set up on each router. Router 1, we put IP version 4 route command and interface. So, right now, router 1 is sending message to router 2, but router 2 is not sending back. We go to router 2 and set up with router 1 PC's subnet number. After that, they are able to ping each other, and show IPv6 route static command will let us to check only static routes. Now the last one, review the chapter 8. I will talk about ROAS and inter-VLAN routing in chapter 8 again, because we learned those things and chapter 8 is simply related with our topic for today and is the most important thing to know. So ROAS, I will use this picture because I couldn't find a great example in chapter 8. So we talk about VLAN trunking, and this is how it goes. I love this example so much. It is very easy to understand. So two different PC and VLAN subnet and IP to transmit the data, they should be together. The reason why it is router on a stick is there is one interface to communicate here with router. This part will be access mode, and this part will be trunk. And router has access to VLAN 10 and 20 because trunking means they're gathering the whole thing together and sending for at once. In addition, we can create sub-interface and we can give each IP address to them. And also, trunking protocol, it is 802.1q to create tags to specify the VLAN ID because we don't want to lose which VLAN is which VLAN. And I would like to talk about another inter-VLAN with multi-layer switch. When we have layer 3 switch with multi-layer switch like this, it supports SVIS, which means switch virtual interfaces. It is logical gateway and there's one-to-one mapping between VLAN and SVI. So when VLAN 10 is sending a message to VLAN 30, the switch checks its routing table and forwards to the VLAN 30 computer through its own VLAN SVI. So SVI exists in here. So we can think about it as a gateway. And this is my citation. Thank you for watching, guys.